Hi, I'm Vasily. This is the Daily Recall Show, and today you will learn how to solve problems like a real inventor by identifying contradictions, by intensifying them, creating a model of the problem, and doing function search. Let's go. So I'll begin with a story, and the story is about crockery, right? So there's things that you eat from, and the crockery problem is basically that in manufacturing of the crockery, there is a process of burning. So when you get a new like a plate, a clay plate, right, or you actually need to burn it for clay to become dry and for this thing to become more robust, more stable. And this burning process is actually a multi-stage process. So it takes like, or you first do the burning, then you somehow measure how well the thing is, and then you actually do the burning again. And this measurement process was exactly the problem, because for measuring the quality of the burned crockery, there were humans involved. So they basically had like a conveyor where this crockery was put after burning, and then they had women standing right above this conveyor and taking one, say, plate, and then hitting that plate with a tiny metal hammer, and then they would listen to the sound of the plate, right? And that's how they determined if it's ready and what kind of the state or the burning is at. And then they would basically sort this thing, either put it to the second burning stage or to ready and stuff like that. So that was the problem they were trying to solve at that manufactory. And the way they did that is basically by automation, right? That's what logic would tell you to do. So that's what a designer approach would be to solving this problem. Or if you're familiar with the designer versus inventor approach, just click here and watch my video on that. But basically, the designer approach is to add more stuff to the system to perform a certain function. And that's what they did. They identified that women are hitting the thing with a hammer is basically a weak chain in this workflow, and that we would have a more efficient workflow if we could have a machine like a robot arm, right, hitting this thing with a hammer. So that's what they did. They built a robotic arm, which would take a tiny hammer, and then another arm would pick up this thing and then hit with a hammer, and the sensoric channel, the sensor would then listen to the sound of the plate. That's how they would identify the burning state. And that's actually a really dumb approach to solving the problem, because if you think of it, like automation has actually really never produced that much of invention, right? So if you come back for a couple seconds to something like a transition from sailing to steam engines, right? You do not go from having a sailboat to having a steam engine powered boat by adding more sails, right? That's not how you solve the problem. The way you solve the problem is by identifying the function and then identifying what kind of technology can you build to improve the function. So the inventor approach to solving this problem would first be to identify contradictions. And contradictions come in three sizes. There are administrative contradictions, which is we need to like improve this process, but we have no fucking idea how. And then there are technical contradictions, which are that if we add this thing, another parameter of the system decreases. So for example, if this chair, if we build it from higher quality materials, then we make less money because we spent more money on buying this stuff, right? And then the third one is the physical contradiction, which is we need to have our A property in the system, but we cannot have A because the system doesn't work. So for example, if you were trying to invent a fan that works underwater, we need to have a motor, an electric motor in the fan, right, to make this thing work. But we cannot have an electric motor because that's exactly how you get a problem with electricity when it contacts with water. So those are three types of contradictions: administrative, technical, and physical. And the way you solve this problem from the inventor approach standpoint is by first trying to identify the contradictions. And the technical contradiction here is that we need to like somehow improve the quality of the process, right? And the way we improve this are from women hitting the thing to like our robotic arm hitting the thing is by basically improving the quality of the perception system, which understands the readiness through their sound of a hammer hitting the plate. So that's like the contradiction is that whenever we get to improve this system, replacing women with robots, we actually have a problem that robots are much more costly than women, like really high quality ones. So whenever we increase the quality of our system that identifies the readiness of the plate, we actually increase the price of manufacturing on the plate. And crockery business is actually a business where nobody makes any money, meaning that there are very tiny margins, and it's not just a viable solution for them to have robots actually do this, because that's not how you make money in the business. So that's basically the technical contradiction. Whenever we improve the quality of this sound recognition by replacing women with robots, we actually have this problem. And the next step you do after you identify this contradiction would be to intensify it and make it as intense as you possibly can. So the correct question to ask would be we need to have this process of understanding how ready a plate is, right? And we need to do that at the highest possible level, but at the lowest possible price, right? So basically, ideally, we need to have a robot which is free that does the thing just perfectly, okay? And this process actually leads you to a very interesting place where you start thinking the right thoughts. So whenever you think like that, you start asking the right questions, which are, do we actually need this thing? Do we need to have a robot hit this thing with a hammer to understand if it's ready or not? And that's actually a really good question to ask, because the next step is to create a model of the problem. And the model of the problem means to identify the components that interact here. And when you do that, you actually understand that the model of the problem is not the women and a hammer and a plate, right? And those things interacting together. The model is that we've got an object, which is a plate, and then we've got the environment over there, which is the heat, right? And those two things interact. So the heat, the environment, changes the structure of the plate, and we need to somehow identify the right place in this process of change where to start doing that. That's the model of the problem. So this is a change problem, right? We've got an object, and then we've got an environment which somehow influences the state of that object, and we need to all we need to do is to identify when it's ready. So that's step 2. First, we identified contradictions, intensified them, and then we created the model of the problem. Why this is useful? Because whenever you create a model of the problem, you can do a thing which is called function search. So what does that mean? Function search is basically when you take the model of the problem and you go across a bunch of industries and you search where this model was applied before, right? And that's actually a really nice idea, because when you go from this automation stuff, right, instead of having women hitting the thing with a hammer to having robots hitting the thing with a hammer, whenever you get to the right model of the problem, you get to understand that it's actually the hammer is not the right problem to solve in the first place. The right problem is this object state change, right? And when you do that, you understand that this was previously done in a bunch of industries, and you get to look across industries and you get to find a solution almost instantly. So, and a good example would be how in radio industry, how resistors get burned. Because that's actually, there is the same exact process. So they also burn the resistors to improve their quality and to manufacture them, and they somehow determine how well those resistors are burned, their state in the change process. So if you look at that, you understand that those resistors are really tiny, really tiny. And you cannot actually hit them with a hammer, so they somehow do that differently. And whenever you do that, you can just pick up the solution to the problem from a different industry. So that's a really nice way to do that. Another example would be from agriculture. So in agriculture, they collect grain from fields, right, using different machines. And there is actually the same problem. How do you determine the state of the grain? Because there is this burning process where grain interacts with the sun, right? Which changes its structure. So that's the exact same model of the problem. And then those guys are who take care of this in agriculture, they actually somehow determine the readiness of the grain. So you just go ahead and pick up the solution, and there the solution is, just for the curious ones, the solution for determining the readiness of the grains is by having two different rays of light are just like focused on the thing, and then you have the bandwidth of the grain and the reflectivity of the grain, or the reflectivity and the bandwidth of the light, which is focused on the grain, and that's how you determine by either, I don't actually remember, by either subtracting or dividing the two metrics, you actually determine the readiness state. So the point is that you never, ever should start solving the problem from the as-is description of the problem, which is those guys, they come and say like, oh, we have this women and we need to like have better women or have more women, and then you start thinking, wow, boy, we need to have a robot. No, that's not the right way to do that. The right way to do that is to identify contradictions, to create a model of the problem, and then to do function storage across a bunch of different industries, and that's how you get to identify a solution. If this was previously done before, which is very often the case, you get to identify the solution, you get to basically pick the model and integrate it into your process. So that's how you solve problems. Please do not build our ships with more and more sails. Please figure out how to go to the steam engine. Thank you very much for watching. Hit the like if you liked it, and see you tomorrow.